This is a LibriVox recording. All LibriVox recordings are in the public domain. For more information or to volunteer, please visit LibriVox.org. The Fairyland of Science by Arabella Buckley. Read and recorded by Patricia Oakley. Lecture 4. A Drop of Water on Its Travels. We are going to spend an hour today in following a drop of water on its travels. If I dip my finger in this basin of water and lift it up again, I bring with it a small glistening drop out of the body of water below, and hold it before you. Tell me, have you any idea where this drop has been, what changes it has undergone, and what work it has been doing in all the long ages that water has lain on the face of the earth? It is a drop now, but it was not so before I lifted it out of the basin, and it was part of a sheet of water, and will be so again if I let it fall. Again, if I were to put this basin on the stove till all the water had boiled away, where would my drop be then? Where would it go? What forms will it take before it reappears in the rain cloud, the river, or the sparkling dew? These are questions we are going to try to answer today. And first, before we can in the least understand how water travels, we must call to mind what we have learned about the sunbeams and the air. We must have clearly pictured in our imagination those countless sun waves which are forever crossing space, and especially those larger and slower undulations, the dark heat waves, for it is these, you will remember, which force the air atoms apart and make the air light, and it is also these which are most busy in sending water on its travels. But not these alone. The sun waves might shake the water drops as much as they liked, and turn them into invisible vapor, but they could not carry them over the earth if it were not for the winds and currents of that aerial ocean which bears the vapor on its bosom and wafts it to different regions of the world. Let us try to understand how these two invisible workers, the sun waves and the air, deal with the drops of water. I have here a kettle boiling over a spirit lamp, and I want you to follow minutely what is going on in it. First, in the flame of the lamp, atoms of the spirit drawn up from below are clashing with the oxygen atoms in the air. This, as you know, causes heat waves and light waves to move rapidly all round the lamp. The light waves cannot pass through the kettle, but the heat waves can, and as they enter the water inside they agitate it violently. Quicker, and still more quickly, the particles of water near the bottom of the kettle move to and fro and are shaken apart, and as they become light they rise through the colder water, letting another layer come down to be heated in its turn. The motion grows more and more violent, making the water hotter and hotter, till at last the particles of which it is composed fly asunder and escape as invisible vapor. If this kettle were transparent, you would not see any steam above the water, because it is in the form of an invisible gas. But as the steam comes out of the mouth of the kettle, you see a cloud. Why is this? Because the vapor is chilled by coming out into the cold air, and its particles are drawn together again into tiny, tiny drops of water, to which Dr. Tyndall has given the suggestive name of water dust. If you hold a plate over the steam, you can catch these tiny drops, though they will run into one another almost as you are catching them. The clouds you see floating in the sky are made of exactly the same kind of water dust as the cloud from the kettle, and I wish to show you that it is also really the same as the invisible steam within the kettle. I will do so by an experiment suggested by Dr. Tyndall. Here is another spirit lamp, which I will hold under the cloud of steam. See, the cloud disappears. As soon as the water dust is heated, the heat waves scatter it again into invisible particles which float away into the room. Even without the spirit lamp, you can convince yourself that water vapor may be invisible, for close to the mouth of the kettle you will see a short blank space before the cloud begins. In this space there must be steam, but it is still so hot that you cannot see it, and this proves that heat waves can so shake water apart as to carry it away invisibly right before your eyes. Now, although we never see any water traveling from our earth up into the skies, we know that it goes there, for it comes down again in rain, and so it must go up invisibly. But where does the heat come from which makes this water invisible? Not from below, as in the case of the kettle, but from above, pouring down from the sun. Wherever the sun waves touch the rivers, ponds, lakes, seas, or fields of ice and snow upon our earth, they carry off invisible water vapor. They dart down through the top layers of the water and shake the water particles forcibly apart, and in this case the drops fly asunder more easily and before they are so hot, because they are not kept down by a great weight of water above, as in the kettle, but find plenty of room to spread themselves out in the gaps between the air atoms of the atmosphere. Can you imagine these water particles, just above any pond or lake, rising up and getting entangled among the air atoms? They are very light, much lighter than the atmosphere, and so when a great many of them are spread about in the air which lies just over the pond, they make it much lighter than the layer of air above, and so help it to rise, while the heavier layer of air comes down ready to take up more vapor. In this way the sun waves and the air carry off water every day and all day long, from the top of the lakes, rivers, pools, springs, and seas, and even from the surface of ice and snow. Without any fuss or noise or sign of any kind, the water of our earth is being drawn up invisibly into the sky. It has been calculated that in the Indian Ocean 3/4 of an inch of water is carried off from the surface of the sea in one day and night, so that as much as 22 feet, or a depth of water about twice the height of an ordinary room, is silently and invisibly lifted up from the whole surface of the ocean in 1 year. It is true this is one of the hottest parts of the earth, where the sun waves are most active, but even in our own country many feet of water are drawn up in the summer time. What then becomes of all this water? Let us follow it as it struggles upwards to the sky. We see it in our imagination first carrying layer after layer of air up with it from the sea till it rises far above our heads and above the highest mountains. But now call to mind what happens to the air as it recedes from the earth. Do you not remember that the air atoms are always trying to fly apart, and are only kept pressed together by the weight of the air above them? Well, as this water-laden air rises up, its particles, no longer so much pressed together, begin to separate, and as all work requires an expenditure of heat, the air becomes colder, and then you know at once what must happen to the invisible vapor. It will form into tiny water drops, like the steam from the kettle. And so, as the air rises and becomes colder, the vapor gathers into visible masses, and we can see it hanging in the sky, and call it clouds. When these clouds are highest, they are about 10 miles from the earth, but when they are made of heavy drops and hang low down, they sometimes come within a mile of the ground. Look up at the clouds as you go home, and think that the water of which they are made has all been drawn up invisibly through the air,